Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib. I am joined by my co-host, JP. How are you, sir?
Great to be here. Happy.
Wonderful. And we are honored to have a wonderful guest today, Leah Elson. This episode of the Health Upgrade Podcast is brought to you by Truvaga. Have you been looking for a simple way to feel calmer, think clearer, and sleep better? Imagine achieving this with just 2 minutes a day. I'm excited to introduce you to Truvaga, a handheld device that supports your nervous system through gentle vagus nerve stimulation. As a doctor specializing in functional health and wellness, I've seen firsthand how Truvaga has accelerated healing in my clients. I've used this device to help people with a range of issues, from sleep disturbances and heart palpitations to digestive dysfunction, nervous system imbalances, and mental wellness concerns. The results have honestly been remarkable. Truvaga is designed to catalyze and accelerate the shift in your body from fight or flight to rest, digest, and recover mode, helping you manage stress, maintain mental clarity, and unwind more easily. It's not just theory. I've witnessed its positive impact on real people facing real health challenges. The best part? Truvaga fits seamlessly into your routine. No need to carve out hours for wellness. Just 2 minutes a day can make a difference. It's a small investment of time for potentially significant benefits in how you feel and function each day. If you're curious to experience Truvaga for yourself, visit truvaga.com/upgrade. You can save $30 on your device by using the code UPGRADE30 at checkout. Remember, that's truvaga.com, truvaga.com/upgrade. It might just be the first step towards a calmer, clearer you, just as it has been for many of my clients. How are you, Leah?
I'm doing phenomenal. Thank you guys so much for having me on the show.
We are excited about this conversation. We've always been of the mind of trying to make scientific discovery, specifically in the health realm, but overall just understanding how we can bring science to the mainstream. And this is literally what you've done in what seemingly is your entire career. How can we make scientific endeavor more accessible to the general population, to the general public? And I think this is such a powerful tool and something that you do beautifully. I'm excited to dig into your story and how you learned about and kind of went through this journey of becoming Leah Elson, who everybody kind of knows now.
Everybody in the world. Listen, if you don't know me, you're missing out.
Totally.
So I think when I'm asked this question, there is this assumption that it's this sort of light bulb moment. And I'm like, you know what, this is what I'm going to do in my life. But science communication for me was quite chaotic, literally, chemically and otherwise, and very organic. So I started just doing increasingly more explosive chemical demonstrations on Facebook Live to entertain my friends. That was it. At one point, and this is a true story, I torched a shower curtain in my bathroom because I was demonstrating the principles of a dual phase rocket engine. True story. Absolutely blew up this shower curtain. And I was like, you know what? Maybe I should take science outside. And through the course of these demonstrations, I had friends that were ravenous for it. And they were like, you got to do this publicly. Because it was just on my little private page just for fun on the weekends. And so I took to Instagram and I just started explaining scientific principles, very slow. And I never assumed that it was going to do anything. It was just sort of a fun, creative outlet for me as sort of an academic. And, randomly it has just blown up and continues to grow. And I find that the general public is actually ravenous for this liaison type science facing human being, right? They want scientists they can relate to and they can learn from. And so I've been holding on with a death grip on the reins as this grows, but it's been phenomenal. It's been phenomenal.
That's great. That's fantastic. I totally agree with that idea that science has become so important in people's lives, but also at the same time, what was it, Arthur C. Clarke or somebody said, sufficiently advanced science is indistinguishable from magic for people.
Absolutely.
And so it's literally like watching magic shows when you see things like people blowing up their shower curtains with dual phase rocket motors, which I'd love to know exactly what it is that you were trying to do. Because I am actually originally an aeronautical engineer. So when you said that, I said, wow, somebody after my own heart there.
Wow, somebody's doing that in their bathroom. What is she thinking?
Yeah. For sure. Actually, funny story. The Jet Propulsion Lab. I know this is supposed to be a health show, but the Jet Propulsion Lab, which is like one of the most famous research facilities in the aerospace and space industries, actually started at Caltech because a group of students were working on a new type of rocket fuel in the dormitory and nearly blew the place up.
That's
and rather
phenomenal.
than getting kicked out, the administration said, you guys are really smart. So we're just going to put you somewhere slightly safer out in the field. Okay. So you go do that out in the field and you keep going. So
that's amazing. I had no idea. I think that that's one of the biggest misconceptions about scientists. I think the sort of trope of a scientist is this sort of geeky, reserved, introverted, but really like they really are cowboys in so many capacities. And I mean, the fun story I will tell you is that I had a friend of mine who I grew up with, and he was an engineer at SpaceX, and he worked on the Dragon capsule. And when they first re-landed the Falcon rocket, it was historic, right? And so he goes, hey, we've basically been given carte blanche on our corporate cards to go nuts in Vegas as a celebration. Come out and hang out with us. And when I tell you that I will never in my life again party with rocket nerds, because they were up for days. They were just going nuts. So anybody out there listening, scientists are they're quite cool, and they're quite cowboy, and they're quite reckless in some instances, but all for the good of science.
They're not all from the Big Bang Theory.
No, not at all. Or they are, but you just don't know that other weird side that they've got to just get out. You know what I mean?
I love it. We outward facing, we're like Sheldon Cooper, and inward, we're a little bit nutty.
Exactly. You have to be.
I'd love to hear what introduced you to science and where your interest kind of began on the scientific side. My kids are like watching the Magic School Bus right now, and they're loving everything. And
classic.
That's kind of one of those classic things that people love to hear about. But everybody kind of has their own story. So I'd love to hear yours.
I never had any science around me. There's nobody in science or medicine in my family. And I think it was just always this very insatiable, ravenous curiosity for the world. And so while kids were, in junior high and they're having like their first kiss under the bleachers, I was literally raising brine shrimp to study their morphologic changes. And so I've just always been curious. I mean, rocks, bugs, plants, whatever it is, I've just always loved knowing the way that things work. And so for me, it was just this innate curiosity. And I always tell parents when they say, how do I get my young kids involved in science? And I tell them just cultivate the curiosity, because scientists are the why kids that just never grew out of it. And so all of this was very just, I think, me capitalizing on what I loved the most, which was curiosity.
Yeah, that sounds exactly like many of the things that JP and I talked about. It's this insatiable desire to just know how the world works, right? And to understand the world that we live in and why it is the way it is. Why are certain things around us the way that they are? And for me, my focus is very much on why the body works the way that it does and how the body interacts with our environment, how internal environments work. And I think that's something that eventually your pathway led you down the road towards that neuroimmunology focus, which is a really interesting thing. So tell us a little bit about how that was introduced to you and why your focus became this neuroimmunology piece.
Because it's the coolest two things in the universe. The brain and your immune system. How could you not want to study those two things together?
A great frontier in medicine. It has been my career in medical research. It's 16 years long, and it has been sort of a pivot point. I was in oncology for a little while. I did the development of novel intraoperative technology for a while. Neuroimmunology is so important. Even just studying the nerves, peripheral nerves specifically, is so important because so many people these days are plagued by maladies associated with peripheral nerve damage, whether that's traumatic, they have a car accident and then, they lose motor function, or they lose sensory function, or, tumor removal, et cetera. There's so many ways that the peripheral nervous system can be angered and can go very wrong. And it's crippling, it's debilitating, it drastically decreases quality of life. And so I started working in the field of biotech, and we specialize in helping to train, educate, and then also intraoperatively help with peripheral nerve repair and reconstruction. So that's what I do, nerve repair and reconstruction. And you see the phenomenal impact that you can make with these patients on their quality of life. When you have a background in oncology, you can develop something for treatment, but you may not see the clinical efficacy and the results for decades, versus something like fixing nerve damage. You can go in and maybe surgically repair nerve and you begin to see results in several months, or, you can start to see the flicker of motor return come back. And it's absolutely enthralling and fascinating, and something that so many people can stand to benefit from. And so that sort of my entire focus in life was I want to impact as many human beings in a positive way as possible, regardless of where that leads me. And this is where that has led me.
So break down for us and for the audience what you've just described, which really is fascinating and incredibly important. But it really, the way you described it was more of how the nervous system functions and how reconnecting nerves and getting nerve signal, transduction to be more efficient. How does that interface with the immune system in your mind? I mean, obviously, we each have a different perspective on it, but how did immunology become part of it? Because you started in oncology, moved to peripheral nerves. How did you integrate immunology into that?
Sure. So the nervous system, both the CNS and the peripheral nervous system, they are immune privileged, right? So they have their own operating system immunologically, and that is by design for the human body. You guys know this very well. But for the listeners out there, this is absolutely by design. This is to keep a really strict control of the homeostasis of these tissues, right? These tissues are very delicate, and the immune system at large is a very powerful beast, right? And so the nervous system, it tries desperately to keep that very powerful beast from coming in, inundating the nervous system and creating inflammation and damage, et cetera, to these delicate structures. And especially because they're so important, especially something like the CNS, right? We don't want any kind of disruption in the central nervous system. And so immunology it plays a critical component in nerve repair, nerve reconstruction, nerve healing, nerve regeneration, right? There is this very nuanced, elegant dance of how the immune system helps to conduct nerve regeneration, how it helps to encourage nerve regeneration, and any kind of disruption or tipping point in that balance or in that signaling cascade results in deleterious effects to the nerves themselves. And so something like, neuroimmunology, what I'm studying right now is how, and if I'm jumping the gun, I apologize, hosts, but it is how gut dysbiosis and a disruption in the balance of your gut flora can actually downstream damage your nerves. And this is something that is it does not make sense. And I actually had a radiobiologist say, within a very thick Italian accent, he worked for the European Space Agency. He was like, tell me, how on earth would peripheral nerves be damaged by something in the gut? Because they're completely different systems. And then my question is, but are they? So you guys shake your head. But are they though? Yeah, they're not. Everything is so intrinsically linked. And as we march forward in our understanding of the human body at large, we're beginning to understand how critically linked the immune system is to the nervous system, to the cardiovascular system, everything. Inflammation affects everything. And so my focus is systemic inflammation, right? Gut dysbiosis causes systemic inflammation, and that deleteriously affects all systems.
I'd love to hear your take on this because you brought it up. What's the difference between acute localized inflammation and systemic inflammation? And I know JP and I kind of have our sense, but I'd love to hear your take on it from that scientific research base.
Of course. So acute inflammation is necessary in the healing phase, right? There is acute inflammation that occurs as a result of an infection or a bit of trauma. And during those initial phases of acute inflammation, it is the immune system's job to go in and clean out all of the damage to make room for healthy tissue to grow and for regeneration regeneration and a return of homeostasis to happen. But acute inflammation is transient, right? That is the delineation. It occurs over. It's supposed to be, exactly. It occurs over a short period of time. It resolves itself. And that is a totally normal part of the healing phase and the healing process. Chronic inflammation is where you get stuck in this. And the way that I describe it when I lecture is like if you've ever had a laptop that got stuck in a perpetual boot loop, or like a phone that gets stuck in a perpetual boot loop, there are these signals that are released as part of immune cells that trigger an uptick of inflammation. But the problem is if you have chronic inflammation, there's secondary damage occurring. So then there's more inflammatory signals being put out, and it just gets in this perpetual positive feedback loop where more inflammation is causing more damage, causing more signaling. And this chronic inflammation is wherein lies the problem, right? There's no back end of that. There's no pro healing. It's just pro damage constantly. And it can be insidious. It doesn't necessarily have to be something. I made a short video on this not too long ago, and people were like, how can I test for it? How do I know? What are my symptoms? And I'm like, the problem is you may be asymptomatic for something like systemic inflammation, low grade metabolic endotoxemia, which is, just this low grade inflammation due to gut dysbiosis. This can be something that you don't know about. It's not symptomatic. You may have like vague feelings, but you could pass it off as like, I'm just tired. I didn't get great sleep, but it could be early signs of inflammation for sure.
And it could be accelerating your aging process.
Oh,
as a
absolutely.
result, because inflammation is inflammaging. You're driving all of those processes that are slowly degrading your system. Yeah, it's just interesting that you're coming at it from a different perspective from where each of us has come from, and we're different, but we're all landing in the same place. One perspective that I have, and I want to sort of test it in your intuition, is that if you go back into embryology, if you go back into gestation and you look to see how did the brain form, how did the nervous system form, how did the cardiovascular system form, how did all of those organs take shape and come to be? It's immune cells that actually build them. Okay, so the microglial cells in the brain are some of the very first immune cells to enter into the embryo, and they come from outside. They come from the yolk sac. They actually sort of extra embryonic cells that invade, and they coordinate the entire building of the brain and the nervous system and the vasculature. And so you're absolutely right. They are part of a very delicate system to control how nerves function, how they regenerate, how you learn, because those are new networks that need to be formed. It's all being orchestrated and choreographed by immune cells. The distraction, I describe it as a distraction. When inflammation occurs and triggers of inflammation, it leads to those cells stopping what they're doing in a good way and starting to do bad things. That's why you can't learn when you're sick. That's why concussions lead to mood changes and degeneration and other problems. But I guess my question for you is, we also know how important the brain-gut axis is, and bringing information up and inflammation, not just information, but inflammation up from the gut into the brain. And how does your intuition meet with the idea or the sense that the nervous system is actually part of the immune system, that they're not different? They're actually two sides of the same coin.
Well, what's fascinating is the gut-brain axis, which is getting a lot of hype lately because we're seeing that there's an association between dysfunction in the gut and like neurocognitive deficits, the development of MS, things like that. And the interesting thing is that the gut and the immune modulation within the gut, all of these cells working together, both microbiotic cells as well as human cells, they produce a staggering amount of neurotransmitters. And so they call it actually, the gut is actually called the second nervous system or the second brain. And there are more neurons innervating the gut tract than there are neurons in the spinal cord. There's tons and tons of them, 100 million plus. And so this sort of delicate dance of the generation of, now you have neurotransmitters, and the gut is actually giving signals to the brain to respond to what it is interfacing with. They're inextricable. I mean, these things are absolutely inextricable. Like you said, both developmentally, embryologically, but also as you grow, as you age, your gut is one of your first interfaces with the world, right? You touch with your skin, you come in contact with things, but the actual first kind of interface is what you're ingesting. thing. And so by design, the human body has evolutionarily adapted to say, okay, well, I'm coming into contact with all these things. Some of them are toxins, some of them are vitamins, some of them are good, some of them absolutely not good. And it is the job of the gut to be the first sentry and to say, okay, this is how we're reacting to the world, what we're ingesting, et cetera. And so, yeah, the gut-brain axis I think it's going to come about that our modern diets, our modern lifestyle, things that are disrupting that communication is really setting up human health and wellness at a huge disadvantage because you're sort of cutting off your second nervous system, your second brain at its legs, right?
Yep.
The effect of all of these lifestyle factors and dietary challenges that we're kind of inflicting upon ourselves affects the microbiome, right? And the microbiota and all of those bacteria, parasites, viruses, yeast, worms, whatever's living in the gut. I would love to get your take on this. In terms of the microbiome, what actually does a dysbiotic gut microbiome mean?
Good question. Yeah. So it can mean, if you look at the profile of bacteria, right, you've got tons of different species of bacteria, all different types, and they all live in this delicate balance. There are some that are really, really beneficial. They help do things like generate vitamins as part of their byproducts. They help with, the generation of neurotransmitters, et cetera, things that are beneficial to the system. And then there are some that sneak in. They're pathogenic in nature. They're the little bad boys. They like to create naughty business. And the problem is that if you expose your gut to a circumstance wherein you allow for pathogenic bacteria to thrive, they will overtake the gut. And so these are situations, like a really good example is poorly controlled diabetes. Hyperglycemia contributes to a shift in that bacterial population where you get these pathogenic bacteria that really thrive in this environment with a lot of sugar. And then they begin to compete with healthy bacteria for resources. And so the healthy bacteria just die off and they diminish. And then you get this proliferation of bad bacteria. And this becomes a problem because not only are they not necessarily contributing to human health, but there are little molecules embedded in the bacteria called lipopolysaccharide, LPS. And this is an endotoxin. And what you may not realize is that this endotoxin contributes to inflammation, as we've been talking about in the gut. And these inflammatory molecules begin to break down the gut barrier that separates the gut from the bloodstream. And then you have this leakage of endotoxin into your systemic circulation.
Chronic inflammation.
Exactly. And that contributes to chronic inflammation. And this is a state that we call clinically metabolic endotoxemia. And it's essentially the same thing as sepsis. It's just a lower grade of it. So, when you get a certain threshold of this LPS, this endotoxin, when it reaches past that threshold, you're septic and you're in the hospital and you've got multiple organ system failure. But you can have an insidious level that's sort of subacute that's just percolating over time. And that's where the chronic inflammation comes in. And then you have atherosclerosis as a product of it. You have breakdown of nerve tissue. You have like acute lung injury and pulmonary issues associated with it.
Disease. Yep.
Exactly. It's just pervasive.
Neurodegeneration. It's
crazy.
Insidious. That's
it is.
The right word.
It truly
is.
I
love that it's called metabolic endotoxemia. And I really want to focus on that word metabolic. What are the metabolic components of how when LPS enters the body, enters the systemic circulation, triggers the immune system, by which I just want to mention about 70% of our immune cells by volume are located in the lining of the gut, which just shows how important that interface of the gut microbiome / gut barrier truly is. When that barrier is broken down by the LPS making its way in, triggering the breakdown or the leakiness of the gut to show up, the immune system becomes hyperactivated. So what's the metabolic specific piece to the triggering of metabolic endotoxemia?
Start with toll receptors. Start with toll receptors and go all the way through. I love it. Good.
Let's talk about TLR4. So metabolic endotoxemia is a product of the immune system getting turned on, triggered by macrophage polarization. And I don't know how deep we want to get in the weeds here, but LPS is very, very triggering for the immune system. The immune system responds so aggressively to LPS. And the reason being, a lot of people are like, why is that? Is because the immune cells, they latch onto it really strongly. And so they can identify it, they can pull it out, and they grab onto it tightly. And then it triggers a bunch of responses intracellularly for them to then in turn release a bunch of chemicals and trigger inflammation. So what they lock onto, this LPS docks onto something something called TLR4 with a couple of like helper proteins. And then what happens is quite fascinating. These then trigger a cascade inside where it actually alters the DNA expression inside of these immune cells. And so you're changing DNA expression to then say, okay, you used to be a helpful immune cell. Now you're just going to be pro-inflammatory, and you're just going to pump out a bunch of signals out into the periphery and into circulation. And so the metabolic component, I think a lot of people use it a bit differently. Metabolic endotoxemia is typically assigned to patients that have dysbiosis as a result of metabolic inefficiencies. So, like I said, something like uncontrolled hyperglycemia, high fat diets, issues associated with just poor health and stress in general. This adversely affects your metabolic system. This adversely affects the way that these immune cells express all of these pro-inflammatory chemicals, and those in turn, they dysfunction things like mitochondria and all these metabolic components. And so it adversely affects your cell's ability to create energy. And so it sort of starts with like the intake of energy and what's going on with how you're giving your body energy to fuel then this hyperinflammation. And then that in turn changes the energy and metabolism of the cells themselves. So a very generalized term, but it affects every single layer of the cascade.
Yeah, I love that. And I think it's an important thing to understand that you mentioned the polarization of the macrophages going, and I realize these terms are antiquated, but M1, M2 kind of polarizations. And we've talked about this quite a bit on the podcast. We have a pretty a group of listeners that are pretty aware of what we're trying to get to and where
macrophage
M1 and M2
savvy.
kind of, exactly.
We love
They're
listeners that are
macrophage savvy.
innate immune system savvy.
Yes, exactly.
We love it.
And where I want to go with this is the understanding that an M1 hyperpolarized towards an activated kind of fight macrophage is generally going to be using glycolysis as its primary method of production of energy. And it's a very inefficient form of energy production, and it triggers
Super
metabolic
inefficient.
dysfunction when you're in that state for too long. Versus an M2 state, M2 macrophage is generally going to be using oxidative phosphorylation, which is a much more efficient form of mitochondrial functionality and metabolic functionality. So just want to focus on those two, but I think that's really where the polarization piece is linked to metabolism. And so it's this idea of immunometabolism. What metabolic state is the immune cell in? And what is that triggering? Is it pushing us more towards a fight state, or is it pushing us more towards a heal and fix and maintain state, which is that M2 polarized?
Of course. Well, and the production of energy at the cellular level is inherently an energy suck in and of itself, right? You need to invest in order to get back. And so when you have a state in which metabolically your cells are processing and creating energy inefficiently, it means you're not getting as much bang for your buck. And so that's why I think there's a lot of issue with chronic fatigue. A lot of people, they experience fatigue, mental fogginess. The brain is a huge consumer of glucose. It undergoes so much processing to create ATP, which is cellular battery. I'm sure you guys probably talked about that at length on this podcast as well. So to create this currency of energy, if you're doing it inefficiently, you're going to be like exhausting yourself just trying to manufacture like little, you're like alms for the poor, little pittance of energy from your cells. And so I think that's where a lot of people, you have these sort of ubiquitous, like, oh, I have chronic fatigue. There's like chronic fatigue syndromes and things, but we don't really understand mechanistically what's going on. But I do think that a lot of this immunomodulatory dysfunctioning systems, I think that they play a really intrinsically linked role that is still being unpacked right now.
From your perspective, is it that the inflammation, I know it's a bidirectional relationship, but we've been talking now about the effect of LPS triggering low-grade sepsis, low-grade inflammation, and the effect it has on mitochondrial function or dysfunction, and talked about how inflammation drives macrophages into an inflamed state that then typically exhibits glycolysis as a method of energy creation. Switching around and thinking about it really from the energy first step and say, when mitochondria are not functioning properly, and it's not just that they're being, shunted away from the system, but they're relying solely on glucose. They're not using fatty acids. They're not using ketones. They're not producing energy not just efficiently, but cleanly. And that's the problem that I see. Is the flip side of it is that when you have a high sugar diet, the wrong fats, et cetera, what you end up with is a dysfunctional oxidative phosphorylation, which leads to the production of reactive oxygen species and free radicals. And they not only damage the mitochondria and the mitochondrial DNA, because mitochondria they're such cool organelles, they have their own DNA. It's like, no, I've got my own.
Bougie.
They're so bougie. So they've got problems with their own DNA, but they're releasing these reactive oxygen species, causing damage inside. That's what we call oxidative stress, is these oxygen species, which we all love oxygen, but they're really dangerous. They go out and they're causing damage to the DNA, to the epigenetic controls over DNA expression. So all of that is, as I said, it's bidirectional. How do you break that cycle? Because the inflammation is causing the mitochondrial dysfunction. The mitochondrial dysfunction is going to continue it. In fact, there's a whole line of research that suggests that this low-grade inflammation that we see in people who have chronic fatigue and fibromyalgia and other widespread pain conditions, or brain fog, or other chronic, sort of almost difficult to control conditions, it's all this feedback, this vicious cycle of mitochondrial dysfunction leading to inflammation, which leads back to, through genetic dysfunction, et cetera, leads back to more mitochondrial dysfunction. How do you break that cycle?
I mean, I think it's a great question, and it leads back to etiologically, what is the source of the inflammation? And I think by and large, a lot of it is modern human diet. We evolved what is suspected to be a relatively low carb, I guess you could say, kind of diet as we evolved as a species. We were scavengers. And so we were eating tubers and roots and, scavenging carcasses and getting in protein and things of that nature. And then we hit the agricultural revolution, and we were able to take half a field of wheat and cram it down into a loaf of bread. And so you're inundating the body with glucose, and glucose is a very sticky molecule. Glucose is something that is, by and large, hyperinflammatory in and of itself, but you're basically forcing the body to metabolize this huge volume of glucose it's never had to contend with. And so it's doing a lot of storage. It's dealing with the fallout of having all of these glucose molecules now in the gut and changing the composition of the gut, pumping out a huge amount of insulin, and like you said, it just causes all of these downstream, secondary, tertiary, quaternary issues, because the reactive oxygen species, like you were talking about, that's part of the immune response. That's a normal part of the immune response, is to have this flooding of these reactive oxygen sorts of molecules to help if there were microbial invaders, because it kills them off. But the problem is you get stuck in that cycle. It just keeps pumping it out, and you're causing DNA damage. And that in turn leads to other crazy things like tumor risk. You know what I mean? DNA damage is obviously underlies all of our oncologic risk. And so you have all of these other issues. And so I think baseline level, obviously this is multi-tiered, it's very complex, but I feel like diet is such an important linchpin in really mopping up the symptomatology associated with people that for a fact, you're that's got to be inflammation based, because it's these vague symptoms. All the blood panels come back clean. There's nothing that you can tell something insidious and nasty and malicious. It's just vagary. And then you look at the diet and you're like, oh, okay, so you had half a liter of Coke today, and you also had all these things, and your body is just sitting there desperately trying to keep up with the damage.
And you're popping Advil or Tylenol, and that's having a weed whacker effect on your gut microbiome. I just recently saw an interview, and I'm blanking on who it was, but she was describing research that she was doing, I think in the Northeast, looking at over a panel of over 1,000 patients' stool samples. And what she found was that out of 1,000 people, only one had the proper level of bifidobacteria in the gut. And that, it is remarkable. And, there's a link between, just sort of, maybe this is a set and you can spike the ball here, but there's a link that we've talked about just briefly on the podcast between gut microbiome and the responsiveness to certain therapies in cancer. And, one in particular is akkermansia. And we've talked about that. But in general, the idea that the microbiome might have a role in modulating the immune system, and the immune system plays such an important role in just surveilling and cleaning out cancer cells because cancer cells occur. We just, if you have a healthy immune system, it cleans it out. But how do you tie in the nervous system? And, I know that Dr. Beebe and I are really interested in the autonomic nervous system, but that's our perspective. I want to hear your perspective. How does all of that together now link back into the nervous system from your perspective?
So the question is which nervous system, central nervous system or peripheral? So we can talk about both, I suppose, but peripheral nervous system is sort of my focus. And a lot of what's happening in this inflammation space that starts with, let's just say, diet. We won't even get into the exercise. We won't get into the stress. We won't get into the antibiotic regimens that are out of control. We'll just stick with diet. So you've got an unhealthy diet. You've got this imbalance of bacteria. You're leaking endotoxins into your bloodstream. This is causing inflammation. And now where this becomes a problem and where the linkage comes in is that you've got this widespread inflammation and a system that used to be immune privileged and separated from this hyper-inflamed environment, which is the entire purpose of being separated. Now you have these little molecules that go and they start chipping away at that wall. And they chip away at it and chip away at it. And then you begin to have this leakage of pro-inflammatory signals into that immune privileged, what is typically sequestered environment. And then that delicate structure that we talked about in the beginning, those things that are hyper strictly controlled so they don't get out of control, suddenly break down. And you start to have this tipping point where now you have hyperinflammation, let's just say in the peripheral nervous system, which is leading to a breakdown of the myelin sheaths that protect the nerve and actually helps nerve transduction, makes it quicker, more efficient. You have a breakdown of that protective sheath. You have a dysregulation of the cells that maintain the neurons that help with that communication. And now suddenly you're like, man, I've got this weird tingling in my extremities, or I have this numbness, or I feel like my proprioception is off, or, I'm having a problem with grip strength as I get older. And that's because that hyper-inflamed environment that began in the gut has now made its way, it's so severe and so insidious, it's made its way all the way to the way that your nervous system functions and sends out motor signals or receives sensory signals. And then for the central nervous system, the same thing. We know that, and there's studies published on this, that those same inflammatory chemical signals, they will break down that wall of the blood-brain barrier, essentially, that keeps everything separate, and they will get in there and start to create inflammation. And you do not want inflammation in your central nervous system. That is a very strictly controlled environment. And so these are things that I think, we sort of take for granted, I'm eating these candy bars, or I love sugar, I'm addicted to sugar, it's my vice. And, what's the worst that could happen? I'll get fat. No, the worst that could happen is you're going to trigger this widespread inflammation that spreads like wildfire and then makes its way to the last frontier, the citadel of your body, which is the central nervous system and peripheral nervous systems. And it breaks it down. And the scary part is it doesn't take that long to break down these tissues. You have enough of this inflammation and it breaks down relatively quickly.
So that was a really good spike. That was a really good spike.
Yes. The set. It was all the set.
But I want to volley back to you, which is the work that you're doing now, which is tying that peripheral neuropathy to the gut microbiome. And just, for those listening, this is really cutting edge work that you're doing. And, why don't you just, you've sort of broken it down, but walk them through exactly what you were expecting to see.
So what I'm expecting to see is that if there is a patient that has chronic dysbiosis, right? So a chronic disruption in gut bacteria, like I said, that allows for those pathogenic, nasty bacteria to sort of overtake the gut. And then it begins to chip away at that gut barrier. You get a leakage of endotoxin into the bloodstream. And then this eventually begins to sort of chip away at that barrier that separates the peripheral nervous system, all of your nerves that supply motor function and sensation and proprioception, all of these things back to the brain, to and from that communication system. What I expect to see is that endotoxin lipopolysaccharide, LPS, that we talked about, will make its way into the peripheral nerves, and it will actually trigger that switch over from, pro-healing, pro-homeostatic M2 macrophages to M1 macrophages. And this is something that has been proven out in many other tissue types, but not yet the peripheral nervous system. So I expect to see that polarization take place. And then what I expect to see is everything associated with that inflammatory environment. You're going to start to see what nerves do when they get scared or damaged. Nerves undergo something called Wallerian degeneration. And that's where there is a point of damage to the nerve. The nerve undergoes cleanup. It starts to break itself down a little bit to then regenerate axons. And what I think is going to happen is you have this chronic state of the nerve going, do I need to break down? Do I need to break down this myelin? Okay, now my Schwann cells, which are normally involved in just maintaining healthy nerves, they're going to trigger a change in Schwann cells. And the Schwann cells are going to start now just being very reactive, right? And being very fight or flight, like, okay, we're going to start breaking stuff down. Stuff that doesn't need to be broken down. It's not directly damaged. It's just a byproduct of the inflammation in your system. So that's what I expect to see. But the beauty of this work is that it applies to so many different populations. So you have anybody with dysbiosis. This includes patients undergoing like radiotherapy for cancer treatment, systemic chemotherapy, patients that have to undergo a lot of antibiotic treatment for whatever reason, patients with autoimmune disorders that have gut dysbiosis. And then something that I am very excited about is astronauts exhibit a lot of dysbiosis. And right now we're struggling with how do we get astronauts through long duration space missions where they're going to be, every single system is damaged, nothing goes unscathed. But, dysbiosis, the point of the work is dysbiosis, regardless of how it's caused, will result in possible peripheral neuropathy, which is a progressive disorder. It's not something that once it makes it past a certain point, you can reverse. So how do we fix it? At the end of the day, take care of all the little guys that run your body, right? Because you are, I like to say, a mechanized meat suit that's just following orders from like a legion of trillions of tiny bacteria. Keep it healthy. The treatment here is prevention. It's prebiotics, probiotics. Something I would love to study is the application of a compound called irinicin A, which is a part of lion's mane mushroom. Lion's mane mushroom and irinicin A specifically, it's a nerve growth factor analog. So can we mobilize it to just sort of help keep nerves healthy in this capacity? And it's crazy because gut dysbiosis and nerve health is only one issue associated with what dysbiosis can actually do at large, which I'm sure you guys have talked about ad nauseum. But
the astronaut situation is really interesting to me. And I think I'm racking my brain, or I've got the gears turning to figure out what that could be. We know they don't have access to fresh food. We know that all of their food is packaged. It's going to be obviously heavily processed. It's just nutrient dense paste that they're taking in, and it's whatever they have for the 6 months they're sitting on the space station. I actually met Sunita Williams, who was one of the
ones that got stuck?
One of the two that got stuck. I met her in Dubai a couple of years ago, which was pretty crazy. And then she got stuck soon after, which was kind of nutty.
She seems like she's super cool.
She is so chill and
she seems
like
so
laid
cool.
back. She's an awesome person. So I was lucky enough to meet her, and this concept of, okay, you've got obviously paste coming in. You're not generally sitting in gravity, so the environment is very different. You're not exposed to sunlight in the same way. You're not exposed to oxygen and nitrogen in the normal atmospheric way. So there's a lot of different factors that could be affecting the astronauts directly.
I think there's a few other things too. What people, sort of the ugly side of spaceflight is that there is very little control over waste products that come out of your body. Okay, so all of that floats around. And, we don't realize that, when we're walking around, moving, et cetera, using the facilities, et cetera, all of these waste products, because of gravity, are falling to the ground, or they're being contained in water and being flushed down into the septic system. Okay, none of that happens in space. Okay, so the cleanliness that you think, space flight's got to be spick and span. It is not.
It is not.
You are floating around in your own waste up there. It's literally floating past you. It's gross. I'm sorry. It's just disgusting.
The toilet system is like a blender vacuum situation, which is interesting.
You might as well just aerate it and put it in the air conditioner.
Aerosolize it.
It's everywhere. So the smell has got to be pretty awful. But think about what it's doing with the microbiome that you're carrying and everybody else is carrying. So there's also a fair amount of antibiotics that are being utilized in order to prevent something really catastrophic from occurring in that soup that everybody's living in. So it's not surprising that you've got a completely dysregulated microbiome in everybody who's in space for any extended period of time.
Well, and to say nothing of the fact that, and this is something I don't think a lot of people appreciate the reality of, is that the radiation exposure is tremendous, even behind shielding. I mean, that's still something that we're trying to get our arms around from an engineering perspective, is better shielding. Because right now, in low orbit, we are still somewhat protected. The astronauts are still somewhat protected from some of the radiation just by virtue of the proximity to Earth. But as soon as you're in open space, it takes 6 months to get to Mars. As soon as you're in open space, the aluminum shielding, it does very little in the grand scheme. And so the gut is being irradiated.
A source of radiation. The high particles hit those aluminum and you get a shower of the particle.
Yeah, so exactly. Just a diffuse array. And so something that I recently, and this was where at the very beginning of the podcast, I mentioned the radiobiologist, who's very Italian. He was heading this up in the ESA. I actually submitted a proposal to study radiation-induced gut dysbiosis as part of this pipeline of experimentation to show, hey, etiologically, it doesn't matter where the dysbiosis comes from, you're going to get neuropathy. And the crazy thing, and no one is talking about this, and it's super exciting and crazy, all astronauts that have come back after long duration missions, you're talking about Vladimir Polyakov, Scott Kelly, all of these guys that had really long terms up in space, they all come back. And as part of their, medical processing, when they get back, they go through like this laundry list of symptomatology. One of the things that no one is catching, and that's part of why I'm so ravenous to get this research done so I can catch it, is that they're reporting proprioceptive disturbance. They're reporting, as soon as they get back to normal gravity, they have numbness and tingling for months thereafter. They're having issues with like grip strength in their EVA suits after a while. And the flight surgeons are like, it's circulatory changes. It's gravity circulatory changes. But circulatory changes due to gravity would resolve very quickly when you get back to gravity. And as somebody in the peripheral nerve space, and there are surprisingly very few of us that are experts in, this symptomatology set, you're like, ding, 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 that is peripheral neuropathy. Like you guys are exhibiting peripheral neuropathy. And the problem is that right now NASA is playing this game where they're like, all right, we're going to go to Mars in the next few years, but we don't know what we don't know about what a risk factor is. And so they're asking all the experts, if you think there's a risk we don't know about, please tell us. And I'm like, I know one that you guys you're misreporting. It's actually inaccurately reported. And I think there's more to the story. So ESA, the whole point with that is that I would get to use a particle accelerator in Darmstadt, Germany at the Helmholtz facility to just zap these mice to essentially sort of replicate space radiation to see what that was like. And unfortunately, at the very last minute, they were like, oh, we want an X-ray arm. And because I'm working with a Dutch institution, I'm like, I can't mobilize an entire country and a Dutch institution in 3 days to do this. So I told them, I was like, hold off. Let me do it on my own with them first, and then we'll come back and we can use this. But yeah, the radiation component is surprisingly overlooked, but is staggering what you get exposed to. Staggering.
You're absolutely right. And this is fascinating. The other thing is just the lack of gravity and what that does. The immune cells, we talk about people coming down from space, they've lost 60% of the mineralization in their bones. Okay. And they say, oh, well, it's just a function of the fact that they didn't need it. Well, okay, that's true. But what happened? How did that demineralization occur? That occurs because there's a shift in osteoblastic and osteoclastic activity. You've upregulated osteoclasts. Well, okay, what's an osteoclast? An osteoclast is a cell that regulates bone growth and bone deterioration because your bones are constantly cycling through growth and basically anabolism and catabolism. Well, those osteoclasts are immune cells. Those osteoclasts are macrophages. They are the tissue-resident macrophages of the bone. So you're talking about the tissue-resident macrophages of the circulatory system becoming dysregulated and starting to remove peripheral tissue, peripheral circulatory structures. You're seeing it the same thing in osteoclasts. I wonder if you took a biopsy of, lung tissue, or took a biopsy of kidney tissue, whether or not you might see that it's a global issue where in a zero-G environment, you have a dysregulated immune cell and these tissue-resident macrophages becoming dysregulated in favor of breaking down. And the reason why I bring it up is that one of the things that NASA's done is they've sent up frogs and other things into space and had them breed in space. It doesn't work too well, okay? So you don't end up with normal looking animals. And the reason for it is, we went back to that embryology. Who's responsible for growing your organs in your tissues? It's those tissue resident macrophages, okay? If the tissue resident macrophages don't have a normal gravitational orientation, they become dysregulated, and the balance between growth and tearing down becomes dysregulated, and you end up tearing down. So you're seeing it in the peripheral nervous system. You're seeing it in the peripheral circulatory system. We all know it happens in the musculoskeletal system, in muscles and in bones. Why would it not also be happening in every other tissue in your body? Because you've literally disoriented your macrophages.
Well, and think about the beating that your kidneys would take, because your muscle tissue is also breaking down. And so now you have all of this hyperinflammatory, protein metabolic byproducts from the catabolism, and it's just being flushed through your poor kidneys, and then in turn causing inflammation from all those breakdowns. I mean, one of the issues when you have organ systems that can't fully break down, protein is ammonia buildup. You know what I mean? And so now you've got possible increases in your ammonia inside your circulatory system, and that's creating inflammation. I mean, it's weird when you develop on a planet with gravity. What happens when you take your body out of gravity?
We talk about all these things about we evolved, and are we carnivores? Are we omnivores? What's the right level of saturated fat to be taking in? We could talk about what's the right amount of exercise to be taking, what's the right time of day to go to sleep. All of these things, people are now talking about thermal regulation and the importance of sauna and ice baths and things like that, because you need to simulate what our bodies went through before we had, air conditioning systems and temperature controlled interior of homes. Well, gravity's pretty important. Okay. Gravity is something that we all have an extreme history of gravity. Okay.
Exactly.
Take that away, and what do you expect? There's going to be dysregulation. There's going to be dysregulation. And so, does it mean we have to design the spacecraft? I'm not saying we shouldn't be exploring. We should be. But should we make certain that we have 1G gravity simulated? Don't stay in 0G for 9 months on, some trajectory that's going to orbit, Mars and get you back here. Don't do that.
Yeah.
Put yourself in a spinning capsule or something, or structure, or maintain 1G acceleration if you can. I mean, that'd be really cool. Get you there a lot faster. But, at the end of the day, we need it. Our bodies need it. Or we need to come up with some way to regulate those immune cells. And that, again, set Spike to Dr. Habib here. What would be a good way to regulate those immune cells out of being inflamed?
Well, I'm sure, Leah, you're going to appreciate this, but and our bias very much is towards the autonomic nervous system, specifically the vagus nerve being the pathway by which we can regulate that immune balancing act that we're playing and shifting away from the M1 and back into the M2, and vagus nerve regulation through acetylcholine, utilizing tools like deep breathing, humming, chanting, gargling, singing. Electrical vagus nerve stimulation is a phenomenal way to accelerate and catalyze that entire functionality. So you set it up, I'll take it down. But I'm very happy that a conversation that began with the topic of neuroimmunology really came down to how we're taking gravity for granted. And I really love it. And this was just wonderful that we got here. Now that we know that gravity is so important to us and we've evolved in a gravitational environment, what are some of the things that we can do for the non-astronauts that are listening today? What are some of the things that we can do? Some of the practices that you've uncovered, not only in your own life, but also in the research, that are beneficial in maintaining that regulatory environment, boosting the neuroimmunology kind of pathways, and ensuring that our nerves continue working.
Oh, absolutely. I mean, the biggest thing, and I stand behind this, I'm very biased, but is activity is a huge regulator of appropriate immune responses. It has so many interesting tendrils into the immune system at large. One, it helps prevent you from being sick, because when you break down muscle tissue, you sort of put the immune system a little bit more on hypervigilance. And so it sort of has the ability to intercept, foreign invaders a little bit faster. It helps with pro-healing, and activity in general. I think that for nerves, the nervous system is very good at, if you don't use it, you'll lose it kind of a thing. And so that's why we encourage people who get older to do things that help your body to maintain those like neuromuscular connections, right? So if you can manipulate objects with maybe your non-dominant hand, or I've seen, people in rehab facilities like pick up things, like use monkey toes and pick up things with their feet and put it in a box, or try to stack things with their feet. It forces the brain to say, okay, there's something going on here that I need to sort of cortically remap and then reshuttle connection to kind of accommodate for what this new ask is. And so activity is such an important thing for maintaining neuromuscular health. And that in turn maintains the health of both your central nervous system and peripheral nervous system. Because if you are telling your body, we need to shuttle energy to maintaining these pathways, it will do so. Whatever you use, it will maintain. Whatever you don't use, it will begin to degrade slowly. And so for me, a lot of this is very big into being active. I love things like trail running or even just hiking, because it forces proprioception and everything to move in a way that, again, we were used to ancestrally, right? We were used to climbing and hiking and running, through uneven terrain. And now everything is paved. You're not forcing your brain to work. You're not forcing your nervous system to adapt on the fly. And that's what it's designed to do. So do things that challenge you from like a proprioceptive navigation kind of aspect. And then obviously earlier we spent so much time talking about gut health. Maintaining a proper diet, prebiotics and fiber is so important. A lot of these bacteria thrive with a lot of like vegetation rich sort of fiber based compounds. Is what they break down as part of their cycle. So eating a ton of vegetables, you know what I mean? Everybody hates vegetables, eat them. You know what I mean? And if you can, eat them raw, because there's a lot of vitamins that actually don't withstand heat very well. Vitamin C is actually one of them. So eat these vegetables raw, get in your fiber intake. And so much of this is predicated on diet and exercise. But what about you guys?
And sleep.
Sleep is huge. Sleep is one of those things where it was like, duh, but it's become a huge focus now, which is important.
Yeah,
but you guys also study this. So you tell me, because I'm curious from your perspective, autonomics.
Okay, so
go for it, JP.
Strap in.
So Kevin Tracy, who's a neurosurgeon, back in 2000 published an article in Nature, which began to unravel the relationship between the autonomic nervous system and the immune system. And what he described was called the immune reflex. And so the practical upshot is that if you stimulate the vagus nerve with the right frequency, you activate in the central nervous system as well as multiple different pathways in the periphery. What he focused on was the splenic pathway. So basically, you send a message up into the brainstem. There's a reflex arc. You send another message back down through the sympathetics and the parasympathetic, leading to ultimately the release of norepinephrine, the sympathetic neurotransmitter, into the spleen. That leads to a group of, which is to me, probably the most fascinating part of this, or one of the two most fascinating parts, is that norepinephrine activates a very special type of T cell. It's a chat cell. So it's got this acetylcholine transferase gene expressed. It has the ability to release acetylcholine. So you have an immune cell effectively acting like an interneuron. Okay. It's taking a sympathetic signal and releasing a parasympathetic signal onto immune cells. Now, there may be some adaptive immune cell play here, but basically when acetylcholine is released onto monocytes and macrophages, there's a special receptor called the alpha-7 nicotinic acetylcholine receptor. And when that's activated, it's an ionotropic calcium channel. When you activate that, there's about a half a dozen different cascades that begin to unfold within the cell that downregulates inflammation, downregulates the entire inflammasome being upregulated. NF-kappa B is blocked. It actually prevents it from dissociating from I-kappa-kappa and I-kappa B. And so you end up with this downregulation of the immune response that would be inflammatory and pushes that macrophage back into a more neurotrophic state in the central nervous system or pro-homeostasis form in the periphery. Now, here's the other piece. I said that interneuron piece was what I found fascinating, but here's the other piece. Really, really super cool here is the fact that alpha-7 nicotinic acetylcholine receptor, which is on the surface of that macrophage, is actually also expressed on the surface of mitochondria. So you have the same receptor on the exterior of your immune cells and on the exterior surface
I don't
of the
know
mitochondria.
how many receptors you can say that about, that it's both sort of extrinsic
Very
and
few.
intrinsic. Yeah.
Yeah. And the cool thing is that gives the mitochondria the ability within inside a cell to monitor what the state of the autonomic nervous system is and inflammation state is outside the cell, because there are specific channels on the surface of most cells that allow acetylcholine to come in. So you have acetylcholine channels that allow the mitochondria. It makes you wonder whether mitochondria are really controlling everything, because mitochondria are actually literally monitoring what's going on outside the cell, not just inside the cell. And when acetylcholine is present, it restores biogenesis, it restores calcium buffering, it restores mitochondrial DNA health, integrity. It prevents oxidative stress from leading to ejection of the DNA and the upregulation of that sting cascade that can be triggering inflammation from mitochondrial dysfunction. So when you're talking about all of the things that are happening in the gut, I'm thinking about that brain-gut axis, which is the vagus nerve, and how changing the firing of that vagus nerve sends that signal up and modulates the entire system's immune system and the mitochondrial health. So I always talk about the fact that there's 4 most important pillars. Like, yes, there's respiration, there's all these other things that are happening in the body, but the 4 most important are your immune system, your cellular metabolism, your microbiome, and your autonomic nervous system. Mm-hmm. And chief among them all, to my way of thinking, although I respect the fact that there's others' perspectives, but it's that autonomic nervous system, because if you regulate your autonomic nervous system, you can control all the other 3.
Well, the vagus nerve especially is so fascinating because of everything it's docked into. You know what I mean? It's like there's damn near nothing that it doesn't touch. You know what I mean? Yeah. It's not actually influencing.
Yeah. That's exactly what brought my attention to it. And I'm pretty sure that's the exact same thing that brought JP's attention to it. It was like, on the macro level, it just looks like a nerve, but it's going everywhere. And so there's not really an understanding of what its impact is going to be. But ultimately, the vagus nerve is trying to send acetylcholine out. It's the only neurotransmitter that it utilizes. And it's trying to send that acetylcholine to those tissue-resident macrophages present in every single organ of the body. And for the organs that it doesn't touch, for the muscle, for the bone, for the skin, it's not directly innervating, but that's where that splenic channel and that amplification through the chat cells is utilized. And so that is really, now that we've understand the microscopic piece to this and we understand just how important the immune system is, the link of these two is so powerfully, like inextricably linked, right? These two are literally tied together. And so we understand that autonomic channel of microbiome, gut, brain, everywhere control is really what's triggering this pathway to, are we going to go into fight state or are we going to fixed state? And can we trigger that M2 healing pathway? And so ultimately, when I'm working, and I work clinically with a lot of people that are dealing with chronic inflammatory conditions, very much so triggered by this LPS initiated leaky gut kind of pathway. And they're dealing with the brain fog and the cognitive dysfunction, and they're dealing with the systemic autoimmunity and whatnot. And we're finding when we eliminate the root cause of that inflammatory trigger, we identify the dysbiotic bacteria, we do some work on the gut health, change some of the dietary practices, really focus on circadian biology. That's where I was going to go with my topics. You mentioned sleep, but it's the whole circadian rhythm of sympathetic when you're awake, parasympathetic when you're asleep. And when you get rid of sleep, you're getting rid of parasympathetic healing time. You can't heal when you're stuck in a sympathetic fight or flight state. Your body cannot. And that's why we enter this chronic inflammatory state and we stay there. And so we do the work of repairing the autonomic nervous system, repairing the lifestyle practices. And that's where we tend to get these really positive results with our patients, because ultimately it's not about a pill, a potion, a single dietary practice. It's about the entire holistic package to enable the body to heal, and the body will do the job of healing. It's not something external that's going to do it.
Amen. Say it louder for the people in the back.
I'm glad we were recording that one. I'm going to utilize that at some point.
That's going on Instagram right there.
It really is.
It's so true, though. I mean, and I think the fascinating thing is that you have all of these components that medicine is now, starting to converge together. And the question is, what came first? It's a chicken or egg scenario. What is the first affront? Where does it stop? Because it's all this feedback loop. You know what I mean? It's like, does it begin metabolically with just something that's innate metabolically, some sort of cellular dysfunction? Does it begin with diet? Does it? But they all feed back on each other, and so it's sort of this sticky. People ask like, what can I do to not have this inflammation? And I'm like, it's a comprehensive. It's not, I can't give you just eat vegetables. It's all of it. And I'm glad JP brought up the sleep thing, that you brought up the sleep thing again. I mean, it's becoming so important. And
it really is. I'm fortunate enough to be working, with the military right now on, some programs around sleep and how we can enhance the value of sleep. Because sleep, we did a whole episode on the three most important things that sleep does. One is lymphatic clearance. You've got to clear the neurotoxic waste out of the brain that gets developed during the process of being awake and alert and thinking and all the rest. Second is your memory consolidation, that taking stuff out of short-term memory or and really integrating it into the cortex. That's all microglial cells. Microglial cells are coordinating that entire process. And if they're not functioning properly, you're not going to learn. You're not going to make good memories. You're not going to be able to recall that information easily. It's almost like it didn't happen for you. And then the last is neurotransmitter and ATP balance. And so, getting proper sleep, you just can't say enough about how important it is. I mean, I'll tell you, I think that if you are serially restricting your sleep, if you're living through chronic sleep restriction, you are getting the equivalent of getting hit in the head with a brick. I mean, it is doing devastating things to your brain. And so
I would be so curious to see what the associated all-cause mortality risk is of sleep deprivation. I'm sure it's staggering. I know people have probably looked at it, but I would love to know what that number is. I mean, I'm sure it's crazy.
Well, there's a seminal paper from 2003 by Belenky, in which they basically took 4 groups of people and looked at various stages of chronic sleep deprivation over just 1 week. And what they found was that there's sort of a threshold where below that, you're going to start to see some diminution in your cognitive functions, but it plateaus. And then below another level, then it's a progressively, it's just a straight line down. You're going to end up with zero cognitive function and brain damage, et cetera. 3 hours a night of sleep every night for 7 days is you've lost 50% of your cognitive capacity. And you are hallucinating. And that goes along with metabolic dysfunction, inflammation, cortisol levels through the roof. All of that is occurring. And that's just 7 days. They say that if you take a newborn animal and you fully deprive it of sleep for 7 days, you'll kill it. It'll be dead.
Oh, sure. Yeah.
So this is, this conversation is just
Lupin.
360s. This is awesome. Like a NASCAR guy who's, doing loops on the
Yeah, I mean,
awesome.
There's a reason why, and morbid as it is, there's a reason why interrogation tactics involve sleep deprivation. You know what I mean? Because it's so disorienting. And I think something that people take for granted is that even though the brain is 2 to 3 pounds, it consumes 20% of your glucose. So if you're up till all hours utilizing glucose, your brain's like, could really use some extra energy there, slick. You know what I mean? Could really use my time with the glucose here.
You actually go for the wrong types of food because, your brain, what I personally like is getting your brain using ketones, using ketone bodies. So hold off on that sugar for as long as possible. Hold off on anything for a long period of time. Get yourself into some mild form of what I call athletic ketosis. Get into not therapeutic, but athletic ketosis where you're just you're like in a flow state. You're doing really well. Yeah. But the brain, if you don't give it rest, it's gonna react poorly. And
you'll know.
And you have to be very specific with how much rest. because I just looked it up, Leah, and
Oh,
really interesting. So this was a review study from 2010, sleep duration and all-cause mortality, a systematic review and meta-analysis of prospective studies by Capuccio et al. From 2010.
shout out
in
Capuccio.
the journal Sleep. And they had results from 1.382 million male and female participants and noted 112,000 deaths. So it's a large scale study. Showed that sleep duration, short sleep duration, which is less than 7 hours of sleep, was associated with a greater risk of death with an RR of 1.12 to 1.18, and with no evidence of publication bias. And long duration of sleep was also associated with a greater risk of death, 1.3, which was really interesting. So
Interesting.
long duration is over 9 hours and low is under 7. So
Yeah, you
7
got like
to 9 is the numbers.
You got a little bimodal distribution there. I would not.
Absolutely.
I mean, I guess I could see it, but I wouldn't have thought that the relative risk would be as close for oversleeping. I would have assumed
Nobody
it would
would have
be.
thought that.
Wow. And it's
Well,
such a.
you have to ask whether oversleeping might be a function of people who might have other underlying
Other issues. Absolutely.
Yeah. And it's obviously that's a tiny little case series, 1.3 million. You can't put it.
There's no way this is
statistically insignificant. Clinically irrelevant.
Clinically irrelevant. I like
that. Is really the fact that we're all laughing about something about like the number of digits on your p-values.
Nerds. Oh, p-value jokes.
This is wonderful, and I love that we brought it back to being these like Big Bang Theory nerds reading the research and laughing about this number of p-value.
We love a bookended podcast. You know what I mean?
It's the best. It really is. This was a wonderful conversation.
Yeah, I'd like to I'd love to follow up with you after the podcast about the work you're doing with NASA, because I think that there's a role. In fact, I'm working with a group of people who are also working with NASA. They've done work on the cognitive enhancement value of vagus nerve stimulation, but I'm thinking about it from the standpoint of what you're talking about, some of the degenerative problems that people experience with long space flight, whether or not some of that could be offset simply by regulating the autonomic nervous system to control the innate immune system.
Yeah. Well, we talked a lot about microgravity earlier, and something that I had pitched to NASA is there's a really easy microgravity model where you suspend rodent hind limbs and you just keep them suspended and you kind of give them free rein to move around their cage just on their front limbs. But it mimics pathophysiologically, I suppose, a lot of the effects of microgravity, like the fluid redistribution to the head, a lot of the immune modulation you see damn near instantaneously. And so, if microgravity work is being conducted in that capacity, you could start to study vagus nerve as well, So it could be, if you guys want to collaborate on something, we could do a peripheral nervous system, vagus nervous system.
I've got little mouse and rat electrodes, so we can absolutely stim them.
I love it. Yeah.
No time at all to do.
I love it. Yeah, I reached out to NASA about it, and we're circling back. And then Space Force is actually waiting for a proposal. So if you guys wanted to jump in, I love using models for different things. To be like, let's honor the mouse and its work. And so it would be super cool.
That'd be awesome. Love to do it.
Amazing. This is awesome, and I love that we've figured out a way to keep the conversation going between us, which is really wonderful.
Exactly, yeah.
Leah, this was wonderful. I love hearing your perspective. I love being able to share this and make science more accessible for people. Yes, we dig into the weeds, but we make it as fun and engaging as possible, and you do a wonderful job of that. Where can people follow you, learn more about you, and just keep the conversation going?
I'm on TikTok. I'm on Instagram. I'm pretty, even though I'm a full-time scientist, I'm very dedicated to the science communication aspect of my life. So you guys can find me at Gnarly by Nature. Nature is spelled with a preceding G. Why? Well, because I thought I was clever and I didn't think this was going to take off, and now it's too late. It's too late to change the name, guys. So we roll with it.
I love it. I absolutely love it. JP, any final thoughts?
No, I'm looking forward to the ongoing conversation. I've got all sorts of research ideas I want to brain dump onto a table and sort through with you. So
absolutely, I'll send you guys the proposal. So now we can be workhorses all together. The Three Musketeers.
Wonderful. Cool. Well, if you got to this point in the podcast, thank you so much for listening. I hope you got a lot out of it, and please share this episode with one person who you think could utilize this information. I'm particularly thinking about maybe somebody who's in university, somebody who is starting off their journey in science, not exactly certain how they want to go or where their curiosity is going to take them, and just to understand that there is a pathway out there for them. And if it's a health issue, this is also a phenomenal podcast to listen to. So please share this with at least one person who you think could utilize this information to upgrade their health. And we'll catch you all on the next one. Thanks for listening.